Hi, this is a metric trial preparation. I took this paper from Western Cape trial for 2024. So let's get right into it. So we given two functions. The first function is a hyperbolic function, right? Then the second function is a straight line, and this one is a hyperbola. Okay, so the first question says, write down the domain of a function f. The function f is the hyperbola, and you know what is the domain is all possible x values of the function. All the x values here, x is an element of a real number, are all possible except at the asymptote, where the asymptote is 3. So this is our domain. So now they say calculate the x-intercept. Calculate the x-intercept of f. How do you calculate x-intercept? You calculate x-intercept by letting y to be equals to 0. So you're gonna have 0 is equals to 2 over um, x minus 3 minus 1. Okay, you're gonna have 1 over x minus 3. This is going to give us x minus 3 is equals to 2. X is equals to 5. So x is equals to 5 is our x-intercept. So now we are required to draw the graph of f. So we have to draw the graph of f of x, which is 2 over x minus 3 minus 1, and the graph of g of x, which is equals to x minus 3. Right. Okay, let's draw our Cartesian plane. Okay, so we're gonna have something like this, and we also very important name our axis. So now we name our axis and our intercept. We have an asymptote at 3. Let's say here is 1, here is 2, here is 3. If here is 3, then we're gonna have an asymptote here. X is equals to 3. X is equals to 3. We're gonna have an asymptote there. We also have an asymptote at y is equals to negative 1. So somewhere around here we're gonna have an asymptote, right? We're gonna have an asymptote where y is equals to negative 1. And we also have a positive here. This tells us that the graph is going to be in the first and the third quadrant because it is positive. All right. Now we have an x-intercept. Our x-intercept is at 5, so we're gonna have an x-intercept somewhere around here. So we're going to have something like this. Then we also have a y-intercept. Do we have a y-intercept? Y-intercept, yes, we do have a y-intercept is equals to 0 here is going to be um, negative 5 over 3, right? Because here is going to be 0. So now we're going to have something like this. Okay, let me just do this. Okay, we're gonna have something like, let me make this thing like this. We're gonna have something like this, right? Then we also have to draw this graph because here we know that here is 3. It has an x-intercept at 3. It has an x-intercept here. It has an y-intercept at negative 3. So somewhere around here, negative 3, it has a y-intercept. So here it has y-intercept. So This is how the graph, it is a straight line. So this is the graph for G, and this is the graph for F. So they intersect each other at that point and also at this point. Okay, so I think we're done. 3.3.4, it says, let me go back and check the question. The question says, calculate the value of x for which the function f of x, which is the hyperbola, is greater than g of x, right? So this function is greater than g of x here. If you can check from this graph, this is f, right? And this is g. Then f is greater than g of x at this point only, right? Because here it is less than, and also here it is less than. And the another important thing we're looking for uh the values of x for which x is greater than 3. 3 is here. So here is the only point where it is greater. So we need to look for this point so that we can know here is not gonna touch the asymptote, right? Up to this point. How do we find that? We find it by its point of intersection. So at that point they are equal. So we can equate the equations. And if we do equate the equations, then we're gonna get something like 2 over x minus 3, x minus 2. This is equals to x minus 2, x minus 3 is equals to 2, x squared minus 3x minus 2x positive 6, 2, x squared minus 5x 6 sorry, 6 minus 2 is 4. This is equals to 0. Okay, so this is the point of intersection. So it intersects at this point number 1, and this is the second point of intersection. It intersects at 4. So we already know that the point here is 4, and if the point there is 4, f of x is greater than g of x from x greater than 3 but less than 4. This is the point where the function is greater than f of x. So we done.